So let us see the plasma in our daily life. You might be notice it actually. Practically, we can see that when we can see a plasma, basically in during lightning, you might be observe lightning. We used to observe the very sharp and very dangerous light. Is it right or wrong? All of you?
Yes.
Yeah. So this lightning basically contains the plasma only. That is what that glare it will come like a glare in the sense of what is the meaning of glare? Anybody can tell me? Yes, please. Glare in the sense of what? Yeah, like a fire.
Sir, our eyes suddenly
Yeah, yeah.
shrills up, sir.
Yeah, that is what we used to say, like angry state or something like a dazzling light. That is what a strong light we used to call it as glare actually. So the light which we are the when we can see the plasma, we can see a plasma basically in chemistry. Next chapter we'll study atoms and molecule. So we'll be having a separate tubes in chemistry laboratory, which we people used to called as discharge tubes. What tubes we used to called as? Discharge tubes. Understanding? So the light during this discharge tube, we will study that in chapter number 3, atoms and molecules. So by the time I'll show you, I think structure of atoms, we will discuss this. So we can see the plasma in discharge tubes. Okay. And as well as also we can see the during lightning also, lightning, what you are seeing is also actually the plasma only. Okay. And as well as some extremely high heat flames, like for example, hydrogen gas burning, like you can take petrol gas, normal LPG cylinder is burning. The flame is very, very, you can notice it, extremely dangerous and as well as very, very high temperature. So that is all the examples. That is what we can say some flames, high level heat flames. Also, we can say examples of plasma. So basically, we can see the plasma in discharge tubes. I will show you in Google what is discharge tubes. Okay. Please mute. Who is that making noise? Okay. So discharge tubes we can see. I will show you the discharge tubes also. And we can see more this plasma during the lightning and as well as some flames. Sam, please mute. One mute means others will unmute means what is this? Next. How many of you know fluorescent tubes, fluorescent bulbs? In our home, you might be having fluorescent lamps. Do you all having? All of you? Yes, please. Fluorescent lamps. Are tube light ra theriyada tube light say?
Yes, sir.
What are people? Fluorescent lamps say theriyada. Fluorescent lamps
Yes, sir.
basically they contains the helium gas. So this actually helium gas and as well as neon lamps. You might be see in your house also you might be having neon gas is present in neon sign bulbs. Okay, so these bulbs basically they contains the plasma state. They are actually ionized to form plasma. This helium gas and as well as neon gas, they have been ionized, means they have been electrons are removed to form what? To form what, guys? Electrons are removed means what it will form? Plasma. Understand?
Plasma.
So they are actually ions now. So whenever the electricity is passed through them, they will start at glare. That is what glowing. So that is how we are getting the light from the fluorescent lamps and as well as neon lamps. So most important
Sir,
application.
one doubt, sir.
Yes.
Fluorescent tube contains helium gas, sir.
Helium gas, but it is ionized to form plasma. Means electrons are separated. Understand, Mari? Electrons are separated from the helium gas. That is what ionized to form the plasma. Then, if you pass the current through this, they will start like a brightening. That is what glowing, so that we used to get light from that. Purema.
Yes, sir.
Yeah. So that is what. And the same way, neon lamps also. We used to call neon sign lamps or neon sign bulb. So they are having a neon gas. They are also ionized to form the plasma, so that they will be, whenever the current will pass through that, they will produce the work. Is it okay, guys? Understand? Clear?
Sir, ionized means what, sir?
Ionized means remove the electrons, Mari. Ionized means they will form into the ions. Ionization means form the ions. Clear? Ionized
Yes,
means to form ions. Okay, guys? Everybody? So to form ions means what we'll do? We'll remove the what? will remove electrons. Clear? They'll turn into ions. Okay, Mari?
Yes, sir.
Ionization process means either addition of electrons or removing of electrons. That is what we used to call as ionize. Okay, wa?
Yes, sir.
Atoms will ionize. Atoms will ionize. Okay, and they'll form ions. Okay, wa? Now clear?
Yes, sir.
Everybody, Sam, Mr. Gokul, that is what. So these are the real life examples of plasma. So let me show you the discharge tube. You people don't know, correct? But of course, I will teach you in the 4th chapter. So plasma in discharge tube, in our laboratory, we can make it. So plasma in discharge tube. Discharge tube is not there. Okay. So you can see plasma discharge tube. So this is what the light will be very, very brightening. So this is what we used to call as plasma. So actually this is a discharge tube. We'll study in 4th chapter to produce the electrons and as well as protons. We'll discuss it. So this is the discharge tube. Sorry, everybody clear? Understand? So we can see inside the light, the bright light. That is what actually, what is that actually? Everybody, plasma. Understand? 4th chapter we will discuss it. Okay. Next, plasma in lightning. Lightning, you can see. So when we are seeing the sharp lightning, this is entirely made up of what? Everybody? The full of lightning is fully filled with what? Plasma only. Clear?
Plasma.
That is what you have to remember. Next, helium, that is what? Fluorescent bulbs. You can see that. So plasma in neon bulbs. Let me take neon sign bulbs. You might be seeing our daily life. Neon sign bulb. Have you seen neon sign bulbs? This is what neon sign bulbs. Okay. So the inside the light which is present, you can even put in market, you can observe neon lamps. So neon lamps, this plasma only present it. This is what. You might be see like these bulbs you never see. Nowadays you can go to any hotels and all. For decoration, they are putting this bulb. Yes or no?
Yes, sir.
Yes. Even
Yes,
saloons and all, you might be notice this one. Correct or not, guys? That is what neon gas. Clear? All of you. Please
Yes, sir.
respond. Next. Fluorescent lamps. So fluorescent light you can see. That is also, this is the bulbs. You are seeing or not in our home. Every home nowadays we are
Yes,
using.
sir.
So this is fully filled with helium gas. That is what ionized helium gas means. Plasma is present inside, and whenever the electricity is conducted, so they will produce the light. Is it understand, everybody? Clear? Now, more than this, all the things in our home, one more instrument is there where we used to say that even the name of the instrument we used to say plasma. We'll start with the plasma. Till now, till today, it is trending only. TVs, special TVs. What is the TV's name? Special TVs. You can see so many types of TVs you can find in our surroundings. QLED TVs, plasma TVs. Have you noticed it? LED TV, plasma TV and all. Yes or no? Please respond, guys. So you might be all familiar. Of course, now we are using QLED TVs and all, plasma TV, like LED TVs and all. But till today, we can see in market, we are having what TVs? We are having the plasma. Understanding? So here, why it is called as plasma TV? Inside, it is containing the charged particles. Do you all understanding? So the charged particles only we used to called as ions. Understanding? So charged ions is present and they will conduct the electricity. So that is the reason it is called as the charged particles only we used to called as what? Everybody? We used to called as plasma. So they will conduct.
So that when they produce electricity, the electrons will also be removed from that, and ions and electrons will form plasma. Sir.
Then only that ions will act like a charged particles and they will conduct the electricity. That is why the TV also will function. Okay.
Yes, sir.
Understand? So QLED, this plasma TV is also example of where the plasma we are using it. Okay. Science in life. So you can remember that. So these are the practical examples where we can see in our daily life. So this is all about the plasma. So plasma means, remember, extremely high temperature of gas. We used to call it as plasma. Is it right or wrong, guys? If the gas is extremely high temperature, then that is what electrons are removed, so that we can use to called as plasma. That's all. Now Sanjay is asking, is the intense spark of electricity in lightning deemed as a plasma? Yes, Mr. Sanjay. The spark of that bright light, which we used to call as dazzling flame. Understanding? A very, very bright light, dazzling flame, we used to call as a plasma. Understand, Sanjay? Okay. So that full light is made up of actually plasma only. That is what you have to remember. Okay. So this is about the fourth state of matter. Next, last state of matter. That is only we used to called as. What is it called as? All of you? We all knows. Please. What is the fifth state of
Yes, sir.
matter?
Bose-Einstein.
Condensate.
Yeah, fifth state of matter. So that is what we used to call. Shivani, understood? Shivani, Alfin, Agalya.
Yes, sir.
Yes.
That is what fourth state of. Fifth state of matter. That is what BEC. Bose-Einstein. Yes, please. Bose-Einstein condensate. Okay. So that is what you have to remember it. Bose-Einstein condensation. Okay. So now let us see Bose-Einstein condensate. Actually, just now we studied plasma is happened at very, very high temperatures or very, very low temperatures. Plasma.
Very high temperature.
Very, very high temperatures. Now, similarly, at an ultra low temperature, we are getting the another kind of matter. That is only we used to called as ultra low temperatures. We are getting the fifth state of matter. That is what we used to called as. What is to say? Everybody? Yes, please. Ultra low temperature of about, all of you remember, room temperature, about nano Kelvin. So Kelvin is the SI unit of temperature. Yes or no, everybody? Please
Yes, sir.
respond. Nano Kelvin, that is almost equals to almost equal to 0 Kelvin. So I will form you from this. Let me see how many of you will say. So 0 Kelvin, we people will get a matter. So that is only at the 0 Kelvin temperature, whatever the state of matter is present, that state of matter only, understanding, state of matter at 0 Kelvin, we used to call as, what we used to call guys? BEC. Understanding? Bose-Einstein condensate. So for example, sir, how sir? Let us see now, all of you. So for example, I am having a liquid water. Do you all understand, everybody? Liquid, what I'm having? Liquid water. Now, I'm saying ultra low temperature. Means I have to decrease the temperature or increase the temperature. Everybody respond. Decrease
the temperature.
Now, all of you tell me, you might be knows SI unit of temperature. What is the SI unit of temperature? Everybody? SI unit of temperature is Kelvin. Is it right or wrong? All of you? And Cbse unit of temperature is, what is that? Cbse unit of temperature is Celsius. Now,
Celsius
can you tell me what is the relationship between Kelvin and Celsius? Kelvin and Celsius. Tell me. All of
so
you.
both are helped to measure temperature.
No, listen. 1 Kelvin is equals to plus 273 degrees Celsius. Understand, Mari? What I'm saying?
Yes, sir.
Yeah,
Yes, sir.
that is what you have to remember it. Okay. Now, so if you notice it, all of you, so sorry, 1 degree Celsius is equals to, all of you observe, 1 degree Celsius. Sorry for that. So 1 degree Celsius is equals to, all of you notice it, we are having 273 kelvins. 1 degree Celsius is equals to how many kelvins? All of you?
273 kelvins.
Okay, so that is what it is, remember. Now, why I want to get it, even not 1 degree, even 0 degree Celsius, that is a perfect answer. So 0 degree Celsius is equals to 273 kelvins. For example, if I say 10 degrees Celsius, which is equals to how many kelvins, guys? How many kelvins, all of you?
2000.
10 plus 273, which is equals to how much, Mari? 283 kelvins. Okay, wow. Understand? Clear? 0 degree Celsius means 273 Kelvin. If 0 become 1 degree Kelvin, 1 degree Celsius, then 273 plus 1, which is equals to 274 Kelvin. Is it okay, guys? Everybody? Understanding? Now, if I made 5 degrees Celsius, 5 degrees Celsius means, which is equals to how much, guys? 273 plus 5, which is equals to how much, Ra? 278 Kelvin.
278.
So that is what you have to remember. Please, all of you remember relation between degree Celsius and Kelvin is equals to 1 degree Celsius is equals to, understanding, degree Celsius plus 273 Kelvin. So that is what it is. So degree Celsius, if you notice it, basically, all of you, that is a relation. So if I take 10 degrees Celsius, which is equals to 10 plus 273 Kelvin. So like that, if I say 100 degrees Celsius, means how many Kelvins? All of you. 100 plus 273, which is equals to 373 Kelvin. Is it okay, guys? Please respond. All of you? Yes, please.
Yes, sir.
So, sir, this is the Kelvin to
Yes, sir.
Celsius, Kelvin to Celsius
Relation.
minus 200.
Relation. Okay, wow. Understood?
Yes, sir.
Okay. Now, I am saying you, all of you observe. Let me take now itself I'll introduce. We're having a Celsius scale and we are having another scale. What is that scale we used to call as? Kelvin scale. Yes or no? So let me take the Celsius scale. Now, all of you observe. We all know melting point of water. Can you tell me what is the melting point of water? Melting point of water. Melting point of water is how much, Ra? 0 degrees Celsius.
0 degrees
And
Celsius.
boiling point of water is how much?
100 degrees Celsius.
100 degrees Celsius.
Clear? Now, let me take this is the Celsius scale. All of you observe Celsius scale, and I will take the another scale is called as Kelvin scale. So now observe very carefully. At the beginning point of, let me take now Celsius scale, we all knows. Basically, it will start from 0 degrees to 100 degrees. Is it right or wrong, everybody? Water boiling point we'll discuss. Yes or no? All of you respond.
Yes,
Clear?
sir.
Now, if you take the water, basically in degree Kelvins, if I want to say, all of you remember, the water boiling melting point of water in Kelvin scale is 273 Kelvins. And boiling point of water is plus 100, which is equals to how much, guys? 373 Kelvin. Understand, Ra? Mari? Clear?
Yes, sir.
Yeah. So if I take now, Kelvin scale is 373 is equals to boiling point of water. Boiling point of water is 373 Kelvin. Melting point of water is 273 Kelvin. Because we all know 0 degree Celsius, which is equals to how many Kelvins? Everybody respond. 273 Kelvin. Clear? Now, I want to go down. All of you observe. I'm going down 273, 272, 271, 270, 269, like that. Keep on coming. So at the beginning of this Kelvin scale, how many Kelvins will come? Everybody. Who is to get 0 Kelvin? Right or wrong scale? Yes or no? Please respond. All of you. Yes. 373,
Yes,
like that will come 273. Next 200, 100, 50, 40, 30, 20, 10 and 0. 0 Kelvin will come or not? Respond. All of you. Like that, if I come down in the Celsius scale also, 0 after what will come? 1 or minus 1? Everybody. -1, -2, -3. Keep on coming. So if I come to this level, so by the time how many digits will come? Can you tell me, everybody? 273 becomes 0. Now 0 become what? Equals to means. Here what will become? Everybody. Minus 273. Is it right or wrong? Everybody? Clear, Mari? Sanjay?
Yes, sir.
That is what. So can you tell me now? 0 Kelvin means how many degrees Celsius? All of you. Minus 273 degrees Celsius. Clear? So at this temperature, what is the state of matter? That is only fifth state of matter. What we used to call as? All of you. Bose-Einstein condensation. Clear? Understood, Amma? Everybody? Please respond. So I will take a water. I'm having a water. which is at 273 Kelvin or equals to 0 degrees Celsius. So if I keep on decreasing the temperature of a water, all of you observe very carefully. When the temperature reaches to the 273 Kelvin, it will reaches to the what? 0 Kelvin.
0.
Means by the
Just
time, what is the degree
minus
Celsius?
273.
Minus 273 degree Kelvin. Now tell me, temperature is keep on decreasing. Now you tell me, particles kinetic energy keep on decreases or increases? All of you respond. When the temperature is keep on,
Decreases.
particles kinetic energy keep on decreasing or increasing? Everybody keep on
Decreasing.
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 And particles will become closer or far each other? Shivani, more far each other or more far each other or more closer to each other? Everybody
More closer to each
more
other.
closer to each other. And observe that the motion of the particles, is it very negligible or they will move faster when they are in minus temperature? Everybody
Sir, by a very negligible small,
very
sir.
negligible. And you can see we will never observe
Yes,
the
sir.
individual movement of the particle. Yes or no? Everybody, Mr. Kishore,
sir.
understood? So we'll observe that the matter behaves as a single component.
Yes, sir.
Entire matter appears to be vibrating or whatever it is, because entire matter appears to be single component, because of by the time the atoms, they're having very low kinetic energy or high kinetic energy? Everybody, they're having low kinetic energy. Understanding? So that is why the kinetic energy of these atoms are very low. So it is very hardly any vibration shown by the atoms. That is why we used to call this one as gaseous superfluid. Understanding? So hardly vibration will take place. No, almost negligible. Entire matter appears to be like single component. So at this state, at 0 Kelvin or minus 273 degrees Celsius, the state of matter is almost we used to called as gaseous superfluid. Sir, why sir gaseous superfluid means? I will explain you. Observe very
Sir,
carefully.
one doubt, sir.
Yeah.
It's in the manner of solid state only, no, sir?
It will not be in the solid state also. I will explain you, Mari. Observe very carefully. So remember, this 0 degrees Celsius, which is equals to 273 Kelvin, and 0 Kelvin is equals to what, guys? Minus
Minus
273 degrees Celsius. Kishore, understand this, Lingesh? Everybody, please respond.
Yes,
All
sir.
of you?
Yes, sir.
Yeah. So this is only we used to called as basically absolute zero. What we used to call? All of you? Absolute zero we used to
Absolute
call
zero.
as. Understanding? Absolute zero temperature. So all of you remember, absolute zero temperature means 0 degree Kelvin, or we can say to minus 273 degrees Celsius. Now, I am saying you, if you want to convert the degree Celsius into Kelvins, all of you remember relation. Celsius is equals to Kelvin minus 273. So that is the value you have to do it. Okay. And if you want to find the Kelvin, what is the relation? Celsius plus 273. Okay, Ra? Everybody, Lingesh, Nivedan. Kelvin equals to Celsius plus 273. And Celsius is equals to what? All of you. Celsius is equals to Kelvin minus 273. Okay, Agalya? How to remove, how to find it? Degree Celsius to degree Kelvins. Okay. Now, 0 Kelvin or minus 273 degrees Celsius, we used to call as what we used to call? Absolute
zero
temperature.
temperature.
Understand? Now, let me take for example, I will draw a graph. All of you remember, I am having a water here. So now, if I am keep on decreasing the temperature is keep on decreasing. So at this point, temperature is 0 Kelvin. What is the temperature here when the water is in liquid state? Example I am saying. What is the temperature, everybody? Yes, please. 0 Kelvin. Now, when the temperature is keep on decreasing, all of you remember, not only water, any state of matter, any kind of matter you take, when the temperature reaching almost to the, all of you remember how much it is? 0 actually. Sorry, this is not 0 Kelvin, guys. I said wrong. What is the Kelvins here? 73 Kelvin. That is what liquid state. Yes or no, Mari? Which is equals to 0 degrees Celsius.
Yes,
Correct?
sir.
That is what. Now, here what is the scale will be present? Anybody can tell me? Here the scale will be present 0 Kelvin, or we can say how much it is? Minus
Minus
273
273.
degrees Celsius. Now, if any matter, if you are keep on decreasing the temperature, decreasing the temperature, decreasing the temperature, decreasing the temperature, all of you remember, no matter will be existed at minus 273 degrees Celsius. This will be surprising for you also. Observe, when the temperature is not necessary to reach to minus 273 degrees Celsius, when the matter will comes almost equals to the minus 273 degrees Celsius or 0 kelvins, the matter will disappear. Matter will disappear. Understanding? So that is why that is called as, what is the name I have written here? Everybody read that. What is this called as? Gaseous superconductor. Understanding? So all of you keep it in mind, at 0 Kelvin or minus 273 degrees Celsius, no matter is existed. Clear, everybody? All of you understand? The matter will completely disappear. So that is only ways to called as quantum state. Basically, you might be heard about quantum physics. Have you heard it? Quantum physics, Mr. Sanjay?
Yes, sir.
Yeah, this is what the quantum physics. Actually, the first such condensate was actually prepared by, this is a MCQ is very important for competitive exams. The first BC, Bose-Einstein condensate is actually first like that matter is prepared by Mr. Eric A. Cornell and as well as Carl E. Weyman. So these are the two scientists in 1995 at the University of Colorado. They have been prepared actually. They prepared or else they produced actually. But why are they used to called as Bose-Einstein condensate? So, and you remember, basically this phenomena was predicted in the year of 1920. Actually, Mr. Satyendranath Bose, that is Indian scientist. Actually, he is from West Bengal. Okay, Satyendranath Bose. Actually, he predicted. He is not proved. Actually, he predicted in when, guys? 1920 itself,
20.
and he predicted this fifth state of matter, and he written a thesis, means a theoretical paper, and he sent it to the Mr. Einstein, and Mr. Einstein analyzed his theory or else his thesis, and he formalized and generalized the idea, which was based on Bose work of statistical mechanics of photons. That is why it is called as Bose-Einstein condensate. This all is not necessary for you. All of you remember, Satyendranath Bose only predicted this fifth state of matter in the year of what? 1920. But they're not prepared. They're not prepared. So
Predicted.
he sent his, they only predicted. And he sent his thesis to Mr. Einstein to the England by the time to the America actually. And Mr. Einstein formalized his all the thesis, and he has been proved. And he has not proved, he has also accepted it. Yes, it is also possible to make the fifth state of matter. So that is why, as Mr. Einstein by the time very world popular prominent scientist, so it has been accepted that the fifth state of matter may existed. That is only called as, it is condensate. Why we used to call it condensate? Temperature is decreasing or increasing? All of you.
Decreases, sir, so condenses.
Temperature decreasing we used to call as what? Condensation. Yes or no, everybody? So that is what we used to call as condensate. Bose is predicted, Einstein is accepted, condensation. Temperature is decreasing. That is why it is called as, what we used to call, everybody? Bose-Einstein condensation. But
Bose-Einstein.
after 1920, 1995 only, Mr. Eric A. Cornwell and Carl E. Wyman, these people, they produced the BEC, Bose-Einstein condensation, by cooling the rubidium gas. Which gas? Everybody? By
Rubidium.
cooled rubidium gas. Please remember. So this all the things for extra knowledge for competitive exams and all. Rubidium gas, they have been cooled to ultra low temperatures, due to which a large fraction of the atoms collapsed into the lowest quantum state. Means matter is disappears. And all of you remember, and they used to produce a what fluid? That fluid is called as, we used to known as superfluid. Okay, so that is what it will happen. So
So
when
what is the matter used, sir?
this matter, we can use it basically in so many applications nowadays. We are using entire quantum physics, because they're extremely like a super fluid, we can say, like having a completely zero vibrations. So we can use this one in
Sir,
experimental.
rubidium is a glass liquid, sir.
Rubidium gas, they have been produced, actually rubidium metal actually it is, but they produced a rubidium gas and they cooled it into ultra low temperatures. Okay.
So rubidium metal only changed into the.
Yeah, rubidium gas also we can produce, Mari. Basically, rubidium is a metal actually, but they produce a rubidium gas and then they cooled into the ultra temperature. Okay.
Yes, sir.
Yeah. So that is what we can get it.
Sir,
Bose-Einstein.
one doubt, sir.
Yeah.
Basically, gas itself, we cannot see it properly. We cannot see now, sir.
Yeah. Yeah.
Then how, sir, they can prove that it disappears?
Gas can be collected. The gas can be collected and they will be condensate in a extremely high temperature, extremely low temperatures, minus 273. So when it is closer to the, when it is closer to the minus 273 degrees Celsius or 0 Kelvin, the gas cannot be visible. Understanding? Everything will be disappear. That is what that state of we used to call as superfluid. Okay.
Yes, sir.
Yeah. So we can use it. We are having so many applications, Mari. Now you will study that. Basically, if you become a chemist, or if you become a scientist, definitely rubidium gas applications will get it. So we are having so many applications, rubidium gas. So that is the reason. Even we will use in some experiments, we will get it. So rubidium applications. So by the time you can learn it, all the things. It's not necessary. Now, if I start reading so many things, it will be goes. That is why. So anyhow, all of you remember, basically this rubidium components will use some electronic applications and all. So because rubidium metal, you might be asked, Mr. Why he has been taken? Rubidium is actually metal, amma, but the advantage of rubidium metal, it will easily converting into gaseous state. That is what is the thing. Rubidium metal easily vaporize, easily vaporized. Okay, and it is easy to convert it also into gaseous state. That is the reason they have been chosen, I think, rubidium metal. Understand, Ra? If you want, you can put it in Google, the paper regarding the BEC, rubidium gas Bose-Einstein condensate. You will get so many research papers. If you want, if you are interested, you can read it also. So this is the fifth state of matter. Is it okay, guys? All of you?
Yes, sir.
Yeah. Yeah.
Yes,
So
sir.
these are the 5 states of matter till today. Okay. But now, latest actually, even the scientists are saying the 6th state of matter is already been existed. We people can prepare. That is what we used to call as fermonic condensate. Okay. So this is the 6th state of matter, which the scientists are expecting that it may be also discovered. Okay. So it is already going on. Lot of scientists are already claiming the 6th state of matter is existed. So this thing, even extremely more temperature, it will exist like matter particles at an extremely more even low temperature stops behaving as a independent particle. So that is what it is. Of course, future, if it maybe it will come. Till now, our education system also not discussing about this one. Just for your curiosity, I am introducing this 6th state of matter. Name alone you learn. What is the name of the 6th state of matter?
Fermionic condensate.
Fermionic condensate. Understanding? So nothing is there. Fermionic condensate means even though very low temperatures, very low temperatures, the particles, who is that? Please mute yourself. The particles stop behaving as independent particles. That is what is happening. Matter particles stop behaving independent particles. So that is what we used to call as fermionic condensate. Nothing is necessary. We will study in higher classes. Okay. So this is what about it. So I hope you all are understand all the 5 states of matter. Anybody having any doubt, please kindly let me know. Clear, guys? Yes, please respond. All of you?
Yes, sir.
Yeah. So this is what about it. Now I will give you one tabular column regarding comparison between solids, liquids, and gases. After this class, I will send you in the group. By tomorrow, you all people need to list out that entire tabular column perfectly in our classwork. And then tomorrow's class, we are going to study measurement of temperature and conversions. Once it is over, then half of the chapter will be over. Then we'll go for the interconversion of states of matter. Is it okay, guys? Everybody clear?
Yes, sir. So that the effects of pressure and effects of
Yeah,
temperature
we'll
are
discuss,
complete.
Mari. Effects of pressure and effects of temperature also we'll discuss while we are discussing the interstates or conversion of matter. Okay, don't worry.
Yes, sir.
Yeah. So thank you, everybody. We'll meet tomorrow's class.